Today's lesson is on ratios with fractions, and your standard is compute unit rates associated with ratios of fractions, including ratios of lengths, areas, and other quantities measured in like or unlike units. And your foldable should be secured into your notebooks already. You have two pieces for this evening's set of notes. One says, when do we use equivalent ratios in everyday life? And the other is a little pamphlet that starts with the title ratios. A ratio can be used to compare two quantities. So hopefully you've secured your notes into your notebook. And I know with the accelerated class, we put our templates a little higher up on your notebook page. So if you need to put vocabulary underneath this little section here, you're more than welcome to do that. But please make sure that you include the vocabulary words in your notes as well. So let's start out with the definition of ratio. The ratio is a comparison of two numbers or measurements. A rate is a ratio in which the two terms are different units. So it is a ratio, but the two terms are different units. And what I mean by that is you may be comparing two different measurements, and they may be depicted in different units. So if you're measuring distance, you may have one in feet and one in inches, or one in inches and one in centimeters. That would be considered a rate rather than a ratio because they have different units. A unit rate is a rate that's expressed as one quantity. Or as one number. And a really common example of that is the term miles per hour, right? If you're going 50 miles per hour on the highway, you're really going 50 miles per every 1 hour you're traveling. So that's two different numbers with two different units that are being represented as one quantity. So this first template kind of to your right does represent all different scenarios where you can use equivalent ratios in your everyday life. So some examples are recipes, reading maps, speed and distance, right? There's that miles per hour language. Comparison shopping, if you're going to the mall, scale drawings like floor plans, or if you're kind of starting out with a project and you want to do it on a smaller scale before making it much larger. Measurement conversions and people-to-people ratios, right? So there's all different places in the real world where we're actually going to be using these ratio ideas and concepts. So starting off, we're going to fill in our little template. It says a ratio can be written in three ways. There are 10 boys and 13 girls in Mrs. Wonderful's class. First of all, you can write the ratio with the word 2. So you could say the ratio of boys to girls is 10 boys for every 13 girls. So 10 to 13. The next component of this problem says write the ratio of boys to girls using the colon. Well, boys to girls is 10 colon 13. Lastly, you can write it as a fraction, 10 over 13. Right, so there are three different ways you can write a ratio: using the word 2, using a colon, or using a fraction. The most common way to write a ratio is using a fraction because that gives you some mathematical freedom that you wouldn't have using words or using a colon. If a ratio is a fraction, you can actually use it to calculate. So it's helpful to practice writing those in that way. Another point to make is that the ratio appears in the order of what is stated. So in the sentence it says there are 10 boys and 13 girls. And notice the 10 is first consecutively, right? If they want the ratio of boys to girls, it's 10 to 13. If they wanted girls to boys, we would change the order and say 13 to 10. As we open up our foldable here, the first flap that you're going to see is this image of the different pets and kind of this interior piece as well. So let's work through some of these problems. A ratio can compare a part to a part. Today at the veterinarian's office, there are 4 dogs and 2 cats. Write the ratio of dogs to cats. Well, I would say there's 4 dogs and 2 cats. I could also write it like this, or 4, 2, 2, right? There's a couple different ways. Write the ratio of cats to dogs. So there's 2 cats compared to 4 dogs. Write the ratio relationship for cats to dogs using the words for every. There are a couple of ways to do this. We could say for every 2 cats, there are 4 dogs. We can also simplify this relationship and substitute the 2 and the 4 for a 1 and a 2. So for every cat, there are 2 dogs, right? So every one cat or every single cat, there are 2 dogs. Usually when you say for every, you want there to be a 1 in the statement, right? If I said for every student, I need, 2 pencils. For every single student, I need 2 pencils. So I have to make sure that I have that ratio with a 1 involved. These next problems ask us to write a real-world context for each ratio. The first one says 3 to 8. I'm going to come up with there are 3 cookies for each of my 8 students. The next one says 6 to 12, and maybe the ratio of red shirts to blue shirts is 6 to 12, right? Then it says, write your last name in the box below. I'm going to do my name, but please do your own name, right? So this is something you're going to have to think about. It says, what's the number of vowels and what's the number of consonants? So I have 1, 2, 3 vowels and 1, 2, 3, 4 consonants. Write the ratio of vowels to consonants, so 3 to 4. Consonants to vowels, 4 to 3. Vowels to total letters. So I have 3 vowels, and then I have 1, 2, 3, 4, 5, 6, 7 total letters. And total letters to consonants, 7 to 4. Right? That might take you a moment to do on your own with your own last name. So please take a second and make sure you're answering those questions appropriately. This last component is the inside tab. So if you open up that last tab we were working on, you'll see that in the center piece of the inside of your foldable has comparing these pictures. A ratio can compare to a part to the whole. What's the ratio of hearts to total shapes? Well, that's 1, 2, 3 hearts compared to 1, 2, 3, 4, 5, 6, 7, 8 total shapes. The ratio of circles to total shapes is 5 to 8. And it says a ratio can compare the whole to a part. So the ratio of total shapes to hearts is 8:3. Total shapes to circles is 8:5. And then it says, remember. And I would say, write the numbers in the correct orders, right? Or in the proper order. We want to make sure that we're actually writing the ratio that's being asked for. Lastly, to finish up this foldable, it says create a drawing to represent each scenario. The ratio of yellow flowers to pink flowers is 2:5. So I'm going to have 2 yellow flowers compared to 1, 2, 3, 4, 5 pink flowers. And then number 2 says the ratio of fish to snails is 3:6. So I'm going to have 1, 2, 3 fish and 1, 2, 3, 4, 5, 6 little snails. I hope those are impressive snails. The ratio of baseballs to footballs is 3:4. That's our last one, right? So 3 baseballs compared to 4 footballs. I want to make sure I'm drawing the ratios correctly. Right? So make sure that all your notes are complete, including the vocabulary words, even if they're not in the exact place on the page that they should be. And fill in your proof problem. What are the 3 different ways we can write a ratio? And then I asked you to use the word Watkinson to write the ratio of vowels to consonants and consonants to overall letters.